Greetings, friends of chemistry. This is the Module 6 practice problems.
They can be found on page 199.
Wow, what a hoopy assistant. Would you come over here so that everybody can appreciate you for your true self? That's so exciting.
This shirt is actually dark blue.
Yeah, I know. I look like I'm wearing some kind of bluish purple, but it's gray. It's okay. My camera isn't the best, but my chemistry is spot on.
Yeah.
Today's the 5th. And practice problems. May you please read number 1.
When 2.13 moles of C3H8 burn in excess oxygen, how many moles of CO2 will be formed? Assume this is complete combustion.
Okay, so we need to know a number of important things before we can do this. We need to know what is complete combustion. So 2.13 moles of C3H8. Is that what you said? Okay.
Yeah.
So burns in excess oxygen. So what's that chemical equation going to look like? It's C3H8 plus
some oxygen.
Oxygen is going to yield what?
H2O and carbon dioxide. Oh, and also that's 2.13 moles of C3H8.
We don't have to worry about that yet. First, we're going to set up our chemical equation.
Okay.
Then we'll figure out how much moles is moles and all that business.
Uh-huh.
Okay, so is this a balanced equation? I'm going to bet it's not. Okay,
Definitely.
Here we have 8 and here we have 2, and so we have to balance this. So the first thing I see is that this is 3. So I'm going to make this 3. Let's start there. That way I'll have 3 carbons. How's that look?
Uh-huh.
Now I have carbon 3, I have hydrogen 8, and oxygen I only have 2. So that's not going to work out. I'm going to need more than that. Over here I have hydrogen 2, oxygen 1 plus 2, so 3 plus 1 plus 6, because I already made that 6, is 7, and C is 3. Okay, so how are we going to get there? I need more of these over here. What if I make that 4? That'll make that 8, and that'll be 4 plus 6. What's 4 plus 6?
10. So then we multiply the other one by 5.
Okay, C3H8 plus 5 oxygen will yield 4 water and 3 carbon dioxide. Let's just confirm 3, 3, 8, 8, 10, 4 plus 6 is 10. Good. Okay, so that's my balanced chemical equation. Now what?
Now we do that mole thing.
Okay, so in order to figure out this, let's say I used 1 mole of C3H8. How many moles of oxygen would I use?
5.
Right, and how many moles of CO2 would be formed?
3.
Okay. So instead, I'm using 2.13. Okay. So the ratio that I'm going to come up with is for every 1 mole of C3H8, I'm going to end up with how many moles of CO2?
3.
3 moles of CO2, or for every 3 moles of CO2, I'm going to have 1 mole of C3H8.
All right, so that's a 1 to 3 ratio. That's not so difficult.
So with this, I want to multiply by some conversion factor and end up with some number of moles of CO2. So which is going to be the right ratio to use?
It's
the one with C3H8 in the denominator and moles in the numerator.
Okay.
Okay. These are our units: moles of C3H8, moles of CO2. Okay. So we're going to multiply by 3 moles of CO2 per 1 mole of C3H8. Because we set it up correctly, our units will cancel, which is what we want. So now we have 2.13 times 3. This is an easy math problem. We don't even need our handy dandy. We can just do it in our pretty little heads or on the chalkboard, as the case may be.
Well, not all of our heads are pretty. Mine is handsome, and Isaiah's is gorgeous, which is different from pretty.
I think you're both rather hoopy. So here we have
Let's just
6.39 moles. How should we worry about our significant digits? Should we report it as 6.39?
No. Yes.
We should, okay? This is an exact equivalence, so we don't have to worry about significant digits here. They gave us 3 significant digits in our initial, so that's the limiting number. The limiting number is 3 significant digits, and that's how many 6.39 has, okay? I'm going to pause this and start a new video for number 2.